Boom. All right. Excellent. Great. Good stuff. Let's see. Why can't I actually see my stream on Twitch? I need to have a little look-see. At twitch.tv. Check out my own stream because I'm cool like that. Not Grimm's. No, I like Grimm's, but not today, thanks. I need to go channels. We need to go home, following, and Mess NZ. There we go. Wow, pretty good. Okay. Sounds good. Let's have a look at, let's see if we can get YouTube board. Switch account. I need to add. Yes, because my audio was all kinds of screwed up yesterday. Deal. And yes. Your password. I have no idea what my password is. Also, figure that out. Yes. Copy to clipboard. Paste. I don't even need to see my own password. Safer that way. There we go. I agree. Google services. Oh, it's installing it to my whole phone. Right. Okay, let's go to view channel. And I should be live. There we go. Let's see how this is sounding. Sounds great. Awesome. Okay, I think I've cracked the multi-streaming thing. Beautiful. So it's a good thing. A very good thing. All right. Now, let's have a look at how my GPU's going. Oh, it's all absolutely fantastic. Okay, great. Finally. Oh, I think I've actually sorted it. Okay, this is good. This is good. All right. Well, now what we're going to do is see if we can get this Keysight program going. We've finished that, so let's go Keysight connection expert. Well, if it's an expert, we have to trust it, right? Rescan instruments. Really? Oh, okay, maybe I've got to plug it in again. Keysight. Gonna quit Slack for now. Utilities. Bin viewer. No installed drivers. That's probably not a good I wonder if there's a way that you can, like, save groups. Ah, got it. Manual configuration. Alright, so remote USB interface. No interfaces were found. Wicked. Well, this isn't going well so far. I mean, maybe in my downloads there was actually like a DSO 2000 software. I dragged it all out of there, didn't I? Handtech Driver. Oh, that's what I just installed. DSO 2DXX. I don't know what that is. Let's run it. See what happens. Oh, there we go. Okay, maybe that's what I need to do. Program files. No, I'm going to go software. Thank you very much, because I like pulling software into there because I'm a control freak when it comes to my computer and where stuff is installed. Oh, I got to get my W-LED thing going as Cozy Fire. There we go. Fire. Beautiful. Nice. Nice. All right. What were we up to? Did I finish installing that thing or not? I mean, I probably got to restart the software, let's be honest. Yep, I don't know what I did there, so let's run this again. And see what happens. Software. All right. Oh, digital scope. Okay, so I don't even know what this is, what this Keysight thing is. Oh, there, device is not connected. Well, that's just a plain lie, because it is actually plugged in. I think what I might have to do is wet and again re-plug it in, because I think my drivers is. Alright. See how this bad boy goes now. Device is not connected. Ugh. USB. Okay. Are you serious? Maybe I've got to restart the... Maybe I've got to restart the scope? This is quite frustrating because it'll be so good to see it on here, and then I can actually, I don't have to aim the camera. Driver. I'm going to exit this. Let's restart. Restart the scope. I wonder if I've got to turn something on the scope. Hardware initialize. It's on. Running. Connect. USB. Device is not connected. Alright, fine. Let's have a look in Device Manager and see what the heck's going on here. So we should have some USB test and measurement devices. Look at that, IVI. IVI Foundation. Okay. USB test and measurement device. I wonder if there's like other oscilloscope software that works with it. Oscilloscope viewer. I don't know. It's not like the data logger that I've got. Oh. That's fine. USB devices. USB test and measurement device. I mean, there must be it. There's got to be the device there, but for some reason Application look. Black style. Okay, doesn't really make much of a difference, does it? It's a very Windows... What is this? Like Windows 2000 or XP or something? Language about digital scope software. Wow. Now I happen to know that repeatedly clicking on the same thing again, expecting a different result, is insanity. So we're not going to keep doing that. What can I do? Maybe it's in the menu of the oscilloscope. I don't know. Let's see. Let's go mobile. Aim the camera at it so we can have a look. It's got a little USB, it's got a little USB indicator down the bottom. Yeah, I mean, there's like no other... Oh, there's no other settings there at all. Alright, well, we'll come back here. Go back this again, alright. Yep, I don't know what we're gonna do. Maybe I could try a different USB port. Sometimes that works. Alright, I'm just going to use my... What happens? Nope. I'm pretty sure I've missed something with this Keysight Connection Expert. Instruments are already discovered and configured. Yeah, but there's like no instruments. So that's not very helpful, is it? I mean, it's entirely possible that I ballsed up the that I've screwed up the firmware, because I remember changing the firmware to something. You don't have serial instruments, remote USB interface, the Visa interface ID. What the heck? Yeah, this ain't going well. I thought this was going to be easy. This is probably something I could have sorted out during the day. So... I don't really want to waste too much more time doing this. Enable remote server. Yeah, I don't think I'm going to get anywhere with this. Which is pretty disappointing. I mean, maybe, you know, maybe a good old computer restart would be in order. Or, actually, one more thing I could try one more thing I'm gonna try is uninstalling the driver and reinstalling the driver. So let's go to Device Manager. And in Device Manager, we're going to go down to that, and we're going to go uninstall device and attempt to remove the driver from the system. Alrighty. Now the oscilloscope's saying I don't have USB on at the moment, which is good. Plug this in. USB. Fires up. DSO2D15. There are no compatible drivers for this device. Okay, well that's actually something. That is called something different to what it was before. Let's go to this digital scope thing again. Okay, so it's still saying not connected. Update driver. Let's search automatically. Yeah. DSO 2000 drivers. Did you try those drivers as stated in the README? Okay. So here we go. This is where you need community answers. Power supply is disastrous. Yep. It's true. It is. It is terrible. Was the nut in the B and C connector was a bit loose, and that was enough. It's jelly alloy. Okay. Zadig. RS Visa setup. Holy moly. This is, hey, what's up? BS2629. How you going? What's going on? What sort of things are you into? Brings you here? I will be entertaining soon. I would love to figure out why my oscilloscope is not connecting to my computer. That would be nice to see some pretty pictures. You think DGens on Twitch are smart enough to understand GoLang? Yep. There's a lot of smart people on Twitch. A lot of smart people on Twitch. Very smart programmers on Twitch too. I'm actually not one of them because I don't know what I'm doing when it comes to GoLang. So, like tonight is the night that I'm using GoLang for the first time, basically. Like, popping my GoLang cherry, could say. Could say that, but nobody does. Oh, what am I gonna do to get this driver working? What are you making? I'm making a... So, I have a bunch of MIDI devices, MIDI instruments, MIDI controllers. And I want to have a stage set up but I don't want to be having I don't want it running through a computer. Like I don't want a digital audio workstation. So what I'm doing is I'm making a MIDI router so I can plug in a bunch of MIDI USB instruments like this little baby synth and some other stuff, and also some hardware MIDI ports, little touch screen, and be able to control MIDI routing on that. And yeah, it'll be called MidiPunk, a little open source project, so anyone can use it, which beats the heck out of buying thousands of dollars worth of equipment if you can't afford it. Yeah, so hopefully that goes well. So far I've just got the Raspberry Pi working and the screen working, so today I want to hook up some MIDI stuff and pull out some MIDI data and yeah, watch that. Yeah, get it into GoLang and start drawing some graphics on the screen with GoLang and stuff like that. See how it goes. Could be a disaster. It might actually work as well, but so far I can't get oscilloscope software installed and working on my computer, so that is not a good start if I'm being completely honest. I know I could find this dang driver downloads. So the Handtech DSO 2000, world's cheapest thing. Oh, here we go. Maybe I should read the manual. They might give me some. Digital storage oscilloscope. Let's have a look. Prepare instrument for use. La-di-da-di-da. I've done all that already. Utility. Waveform. This has nothing about connecting to a computer, so unless I just totally skipped over it, but connect the oscilloscope. Yeah. I don't know. I think I'm going to give up on this and just get into programming because, you know, that's really where I want to be right now. I know how to use all that stuff. Blah, blah. Okay. Let's have a look. Close this down for now. I'll admit defeat for the time being. Maybe I'll sort it out tomorrow. And let's get this Raspberry Pi hooked up. Oh man, I don't have the power plugged in either. Oh, maybe I do. Yay. Okay, so the cool thing, alright, yeah, this is good because this actually powers the little synth. Plug that in so it actually makes noise. Anyway, so the Raspberry Pi is starting up, so I should be able to SSH into that any second now. Go terminal. Go SSH MIDI, whoops, MidiPunk.local. Oh gosh, typing again. Start her up. Right, so where was I? Basically, yesterday I got to the point where I installed the UART ports. So now I've got 4 of the damn things to play with, which is really cool. So what we might do is have a look at TTY AMA 0 and see if we can't get some MIDI data coming in on that. So yeah, that would be grand. What I should do while I'm at it is actually make the circuit schematics as well. MIDI Muse keycad. Holy moly, does this have a dark mode? That is assaulting my eyes right now. Icon theme. Oh, it's so bright. Display options. They're like a theme. Colors. keycad classic. Ah, it doesn't ship with a dark mode. That's alright. Maybe, you know, I'll just have to... My eyes will just have to adjust to looking into the sun right now. So let's place a component. Let's go add component. And we are going to... Oh, that's really... really stressed out my computer. Okay, filter. We want a photo coupler. Isolator. Isolated linear photocoupler wideband. Dip 8. Photo MOSFET. No, I just want a photo transistor actually. Photo... Oh! Shivers. Photo transistor. So I want SMD, I think. Optocoupler. There we go. This is what I want. This is the stuff. Now, what version of this optocoupler do I want? I don't need a dual one. I just got a really crummy, crappy one. I don't know what any of the stats are of it. I just know that it works. So I'm just gonna... No. I mean, these look right. These look correct. I guess the packaging is the thing that's different here. So I think it's one of these because it's like got the legs a bit further out. So yeah, I'm just going to use one of those. Pop that there. And we're going to go and see if we can find a 5-pin DIN socket. DIN 5. 5-pin DIN connector. 180 degree. Wait, are mine 180 degree or are they... Yes, they are. I mean, not that that matters. This is a schematic, so... One, two, three, four, five. Okay, that works. Mini DIN. No, just DIN. DIN 5. Just be done with it. That's good. That's what we got. Okay. Use a MIDI DIN connector. Beautiful. Okay. What else do I need? I need some resistors. I think from my little mock-up here, I've only used 2. So we're going to use 2 resistors. I don't know where I'm going to put them yet, but how do you duplicate? Is there a way you can like copy and paste? Oh, there is. Alrighty, and then we're going to have so like how do we flip this over? Maybe I don't. Okay. Oh, look at that. You can rotate these. Who knew? That's pretty handy. Okay. Cool, cool. So transistor side's going to be on that side. That's going to be the output, which goes to the Raspberry Pi. So yeah. Let's make some wires here. So we got to look at our MIDI wiring reference. MIDI electronics reference. Here we go. This is exactly what I'm trying to build right here. So MIDI in. So positive goes to pin number 4. The cathode is pin number 4. The pin number 4 goes to that, and pin number 2 simply goes to pin number 5 on the DIN connector. But that's not 100% right, is it? We want a resistor on that line there to limit the current flowing through the photodiode. Now, if we look at the data sheet for the photodiode, I'm pretty sure I did save somewhere. Pretty sure I did. Pretty sure is not 100% sure. Data sheets. Electronics. Maybe I didn't. Okay. Probably going to help if I figure out what PC 817C. 817C. So we'll just go PC817C. We'll just change that text. I don't know what that is, like... Oh, it's... Okay. U1. R1. And the value is going to be 220R. We just want 220... Now, this is going to be 5 volts. So how do you flag that you've got a 5 volt power source? Yeah, so we go add plus 5 volts. I don't actually know what all this means, like VL, VP, and all that sort of stuff. It probably would be pretty... good to learn that, you know. What does 5VL, 5VA mean? That would have been a shame if somebody answered that question, because that's exactly what I want to know. Symbol library. Yeah, well, this is just literally what's in the software browser. Alright, well. Okay, that's fine. I'm just going to use 5 volts. I'm just going to use 5 volts. I like the way it's got the arrow pointing out of the circuit because it sort of shows you the pull, the pull of electron. Yeah. Good. That's 5 volts there. So we got R1220R. So if we go and bring up our calculator and have a look at this, we're gonna V equals IR, right? So volts divided by 220 equals 0.023 amps, which is 23 milliamps. Right, so now I need to, no, I don't want to do that. Get out of there. I want to go and look up this part, which is a PC817C data sheet. Beautiful. Gosh. Can I just have, like, maybe I shouldn't go to all data sheets because this always does this to me. Sharp semiconductor. Cookie settings. Yeah, good. Choices. Digikey.co.nz. And what do you want to bet? It's going to navigate me away from exactly what I want here. Okay, I'm just going to right click. Is there a way I can download PDF? There is. Nice. Okay, so here we go. Let's have a look here. Pins 1 and 2 are called the... Pins 1 and 2. Forward current 50 milliamps. Peak forward current 1 amp. Pulse width. Okay, well that's tiny. I mean, that's ridiculous. And duty cycle of 0.001. Right. No problemo. None of the stuff we're exceeding. So collector current 50 milliamps. Is this, oh, this is absolute maximum ratings. So we are not allowed to exceed 50 milliamps on either side of this device. So 50 milliamps is the absolute max. So if we are looking at, yeah, this, we definitely only have 23 milliamps going through it. So that is fine. 220 ohm resistor is all good in the hood. All right, so now we want to have a we need 3.3 volts, 3v3. What? Wait, there it is, 3v3. 3.3V. Yeah, that'll do. All right, so we'll chuck that there. This is where this confuses me because, like, in terms of a transistor, the arrow is the flow of electrons. But this 3v3 is the pull. Wait, no it isn't. What? Hold up. Let's ask chat. Let's ask our AI overlords what they think about this. Have I got this wrong? Is this my brain being weird? In electronics, just in general, like, what's the in electronics in general, what's the direction of the arrow in a transistor symbol representing? Directional of conventional current flow, the flow of positive charge. Right. Flow of positive charge. Current flows out. Not pointing in. NPN. Not pointing. The arrow always shows emitter current direction in active mode. So, hold up. The flow of positive charge. Right, conventional current flow. So the flow of positive charge. The flow of positive charge in this case is out that way. Towards the ground. Okay. Oi, oi, oi. Now, okay. So we're going to have this feeding that, and then we're going to feed the resistor, or the resistor is going to limit the current flowing out of that transistor. Again, it's going to be the same. It's going to be 220R, and that is going to flow out to ground. So we need another symbol, which is going to be ground. Signal ground. We'll just use ground. That's simple. Simple like me. And then we go wires. Whoopsies. And then we go wires, and we're going to add a wire there. Boom. Groundy, groundy, ground. Good stuff. Excellent. So that's our little MIDI in diagram. So is there a way in this that we can like group things? Align items to grid. Spect. Electrical rules checking. No, we don't want. Update schematic from PCB. Update PCB from schematic. So, errors 3. Replace footprints with those specified. Errors. Cannot add J1. No footprint assigned. Cannot add R2. No footprint. Yeah, okay. Well, that didn't do anything. Delete footprints with no symbols. What? Creepers. How do you do this? This is all brand new to me. It's very cool. I like it. And I don't know what that is. Is that silkscreen? R1? So how do you like add how do you add resistor footprints? I guess I'm gonna have to look that up. Footprint editor. Footprint library? 3D viewer. Okay, so maybe what it is like you actually have to assign a footprint on the symbol here. So is there like a way to specify what footprint to use? Yeah, there. Footprint. Nice. Are there resistors? Resistor. Surface mount. Resistor. THT. Resistor array. I don't want that. I just want an axial resistor. Length 3.6 millimeters. This is where I need my... That's where I need my calipers. So I'm going to do that. I'm going to get another drink. Be right back. All right. I didn't get the calipers. Jeepers creepers. Alrighty. Okay. I now have calipers. I can now measure teeny tiny little resistor. Right. Is precisely 6.3 millimeters. Sit down, kitty cat. Beautiful. What does show mean? I don't know. Ah. I mean, that makes sense, doesn't it? But we actually don't want, we definitely don't want to show. Okay, so now if I went back to my PCB, and in fact, actually, I'm going to go footprint, and we're going to use the same footprint. We can that one. We're not going to show it. Yeah, so that's cool. All right, so MIDI jacks is probably going to be a little bit trickier. So if we go back to the PCB here and we update PCB from schematic. I now have the I mean, okay. This is starting to look. What is all this? I don't understand. Is this like, are these just are these things, what is that? What is that label? Like, is that a thing? What are positioning tools? Okay, I'm getting so distracted here. I'm just mega ADHD, right? So the one big thing I'm missing here is the frickin' signal. Like, where's the signal come from? Signal comes from here. So we are going to put a little 2 UART symbol. So how would that, what would that look like? keycad. Symbol to pin. So like an output to a pin. Symbol output. So I'm not sure what to use for that. Let's go into the library and see if there's something like output, or like, yeah, output. In. I'm gonna remove these pin messages. Don't need them anymore, because I'm pretty sure my stream is fine. Good. All right. Sorry, there was a random moment of silence there. Rip my brain for a second. What the heck do I use to represent an output in KiCad? I think I'm going to have to go back to old chat search. I feel bad for doing this, but Google wasn't helping me there. In KiCad, I have... Yeah, no, see, now my phone's thinking I'm talking to my phone. Dare I say the G word again? I'm not going to. Okay, I am making a schematic where the output will be connecting to the GPIO pins of a Raspberry Pi. What symbol? Whoa! What is that? Okay, I accidentally control V'd. Derailed me. No, what symbol should I use for this? Go. Really? Actually bring in the GPIO header? Okay. 40 pin header. Yeah. I mean, I guess it makes sense. Or the generic Con 2x20. Okay, I could do that. Use net labels and a clear comment block. The hell are net labels? I love its awkward laughing, like when you say something like that. It's trained my chat well. Right. Net labels are just names you give to electrical connections, so that KiCad knows they're the same, even if they're not physically connected with wire. I Think of them like name tags for signals. Instead of drawing a messy web of wires all over the place, you can slap a label on each end of the connection and keycap will know they're connected because the labels match. Okay, that's cool. I don't think I'm going to do that. I think I'm going to do this old 40-pin header. Raspberry Pi. No, it's actually all labeled? Is that... Are you serious? So, what if I don't want it... I want... Okay. Whoa! Keen. I like this. Alright. No. I'm keen as. Does this have a footprint? It doesn't. What about a generic 40-pin header? In header 2 by 20. Oh, 2 by 20, eh? That's what we're looking at. But I'm not actually using a 2 by 20 header on the I'm not actually using a 2 by 20 on the circuit board. So really what I need is just like a jump pin or a like a what are they called, like a screw connect. What's a good way to do this actually? I don't know. I don't want to just use push connectors, but soldering would be nice. I mean, I guess I could unsolder the header from the Pi, but that's just such a pain in the butt. I want to do that. I do have a few 2 by 5 connectors I can push onto the header. Would use those. I don't know. Anyway, let's maybe not use anything at the moment for the footprint. So this is going to be ground. We're going to select that. We're going to go copy, paste, ground. A lot of ground pins on the Pi, so and that is all going to be connected together because yeah, see, these two connect. Place net labels. Label. I'm going to call this 3v3 from Pi. In one. What does that look like? And so, how does it know that? Is it? How do I know that is applied to that line? Like, huh? Wow, that's really weird. Is there a way I can move that? Oh, it looks right now. Really strange. What? I don't fully understand this. Maybe I should just delete that. Go like that. And then this here, we can do the old label again. Do the old label properties. Add a label there, and we'll go free. Oh, wait, because this should be in the drop down, right? Yeah, okay, I get it. Cool. Yeah. I get it. It's okay. So vertical justification, center. Really do a great job, did it? Maybe just do that. And then we're going to have to rename this. 3v3 type. And is there like a horizontal justification for this? Yes, there is. Then we'll go vertical. Top. Whoa, no. Bottom. Bottom. Top. Oh, that's so unsatisfying that it doesn't act. It really doesn't matter though, does it? So, now the signal tap is going to come off the signal tap's going to come off this line here, right? So generally what it's going to be, MIDI and UART in this case is idle high. So when it's 3.3 volts, it is representing a binary 0. So what happens is when we get a MIDI signal through here, that is going to cause the current to flow through that resistor to ground. Wait, no, it's gonna wait, hang on a minute. Wait one gosh darn minuten. That doesn't make sense. I'm gonna have to test this on the breadboard. I can't remember how it works. Makes sense. There should be 3.3 volts. When the transistor's on, it should allow current to flow to ground, which means the voltage there will be 0. Okay, but anyway, what I do know is that the wire tap comes off here. And it goes to... Now this is going to be... this is going to... We're going to duplicate this a number of times, but I'm not going to do that right now. We're going to have a look and see our electronics reference here and at our pinouts and UART and see what pins we've got available to us. So we are using UART 0, 2, 3, and 5. So UART 0 are pins 14 and 15. Okay, so this, in this case, this is the MIDI in circuit. So this is dealing with a input MIDI signal. So input is going to go to the RX port of the Pi, which is 15, GPIO 15. All right, we might just do this label thing again because I actually really like it. I think it's really tidy. No, I don't know what I'm doing with electronics, really. Good, doesn't it? How do you just stop the line there? Get out of there. Which finish end. Exit. How do I just move this? It isn't it? Like, why does it do that? Right, now we're going to label this. This label is going to be GPIO. What did I say? 15. Memory of a fish sometimes. 15. rid of this? How do I get rid of this? Syntax help. Okay. Markup. Overbar. Block. Oh, cool. Okay. R3. Value. Bus definition. D. 0 to 7. I don't need to do that. We're just going to go for GPIO 15. Vertical justification center. I don't need to justify why. Sounds right. What is me? Oh look, I had RxD on there anyway. Control C, Control V. On there. Gonna go horizontal justification right. Vertical justification. Cool. Yeah. That's nice. Is very nice. So at the moment, I mean, this is only RX. What I do want to do is have MIDI DIN out as well, and I won't have them assignable. I want to be able to switch them based on a GPIO. And then I'm gonna need to step them up to 5 volts. I can probably do that with a transistor. Just a simple transistor circuit. I don't need... I wonder if I can do that. Step up 3.3 to 5 volts with a transistor. I don't think it works that way. I don't think I can do. We might need to ask old chat here if that is going to work actually. Let's see. So I need to step up a 3.3 volt logic signal to a 5 volt logic signal. Not a super high rate. 31.25 kilohertz max frequency. Actually it'll be double. Would it be double that? Because of 31.25 bits per second, which means it's probably about 100 kilohertz max frequency actually. Can I just use the cheapy transistor based circuit to do this? Yeah, of course I can. Add a modest frequency. Heck yeah, I like that. Popular dirt cheap circuit, MOSFET level shifter. MOSFET? Why do I need a MOSFET? .3 volts. These diagrams honestly never make any sense. They don't do anything. Gate connected to 3.3. Okay, so the gate is the gate. It's the thing that opens and closes, blah, 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 blah. Reacts to the digital signal coming from the Pi, 3.3 volts. Okay. Open, close, shut the gate, blah, blah, blah. Then we've got source on the 3.3 volt side. And the drain on the 5 volt side. I don't actually get the source is always from the ground, right? So the source is actually connected to ground. That's where it pulls that's the electron source, pulls them from the ground. Okay, so pulls the electrons from the ground. I need to, I can't imagine this. Like, I need to think about this in a different way. I need to draw a different diagram, I think. Gate connected to 3.3. That makes sense. I need a better diagram. The circuit relies on the MOSFET only turning on when there's a logic low on one side. Translating that correctly to the other. Works well up to a few megahertz. Oh, okay. Not ideal for precise analog or very fast edges, but for that. Bidirectional. It's not what I want. I just need a unidirectional 3.3 volt to 5 volt step up. Is there any way of using non-MOSFET transistors like NPN, ENP? Oh, I don't know. BJTs, that's it. 3.3 volt logic signal controls the base. When the 3.3 signal is high, the transistor turns on. Yes. Pulling the output low. When the 3.3 signal is low, the transistor is off. And a pull-up resistor brings the output to high, to 5 volts. You get an inverted 3.3 to 5 volt signal. Inverted. I don't want that. Maybe I do. Maybe I could. Maybe I do want an inverted signal, actually, because I want the 5 volt to be grounded when, but I mean that's partly going to be determined by the UART output of the Pi. You'll need a second stage to flip it back. I mean, that's okay. These schematics... Oh, it kind of does, actually. There's the charge emitter, charge collector. I think we're just going to have to try this. I think we're just going to have to breadboard it up and see what we can do. Depending on transistor gain. Well, up to 5 volts. I still get confused by this sometimes. Like, can you explain why the 10K resistor is called a pull-up resistor? What's its purpose here? Resistor connected between a signal line and a positive voltage. So there, that's the signal line and a positive voltage. And it's connected between the two, right? So we've got a resistor there. That causes current to flow. When the transistor is on, it acts like a switch to ground. Yeah. So when this is on, the 5 volts just flows directly to ground, right? And it flows directly to ground through the current that flows to ground is limited by the 10K resistor. If it wasn't, we'd just freaking explode and blow up and short circuit or something. So basically what we're looking at here is we're looking at 5 volts divided by 10,000, which is like 5 microamps or something. No, it'd be like 500 UA. 0.5 milliamps. Whatever the heck that is. Yeah, okay, so very, very low current leaking through the ground in that case. But nonetheless, that will still mean that the potential difference will be 0. Okay. Now the idea of the base resistor is to get some current flowing. When we've got 3.3 volts, we need to get enough current flowing into the junction and out the emitter. So that's about 5 milliamps at 3.3 volts, which should be enough to saturate the junction and cause the current to flow. So 3.3 goes in there and out the bottom. Or is it the other way around? I can't remember. But anyway, whatever. Okay, that's cool. I think I'm starting to get it. When the transistor is off, okay, when it's off, it's like an open circuit. The collector isn't connected to anything. Yes, the collector isn't connected to anything. So, in other words, it's like a block. It's a wall. So the current will not flow. If you didn't have the pull-up resistor, the output would be floating. So how does it actually do that, though? It's like how does it actually... Okay, I don't fully understand why the voltage would be floating without the resistor. What does that mean exactly? And how does the resistor stop it from floating? Yeah, once you get it, it clicks forever. All right. It is not connected to any definite voltage, neither high nor low. So its voltage is unpredictable. Okay, I mean, that makes sense. Imagine a wire hanging in the air connected to nothing. It's not grounded, it's not connected, it's just there. It's a floating node. Okay, what happens when something is floating? It can pick up noise from nearby signals. Yeah, so it acts like an antenna. Voltage on it can drift, bounce around, or flicker, even though you're not doing anything to it. Logic circuits might randomly read it as high or low at different times, causing weird, unpredictable behavior. Definitely had that, like, definitely seen that. Okay, the collector is disconnected. There's nothing there to set the voltage, so without the resistor, the output pin is floating, undefined. With the pull-up resistor, it's weakly connected to +5, so the voltage naturally settles to 5. Imagine having a balloon on a string. If the string is tied to nothing, the balloon might just drift wherever. If you tie the string lightly to a ceiling, it naturally wants to stay up there. But when the transistor is off, I get that it's not like shorted to ground, or but I don't know why it's not connected to a voltage. That wire is still coming from 5-volt source, and the other end is connected to a digital input, presumably. So and presumably that digital device we're connected to is also grounded. There's got to be something simple I'm missing. Pull up output. When the transistor is off, the path from the collector to the emitter is open. Transistor is not conducting. So the collector, and therefore the output, is only connected to the 5-volt supply through a 10k resistor. And the digital input in of whatever. So why isn't this Because the connection through the resistor is weak. Okay. I just had like... Sometimes you just get that scratchy feeling in your brain when you feel like you're getting something. Maybe that's what's happening. A resistor limits current. The 10K resistor is allowing only a tiny trickle of current, 0.5 milliamps, from 5 volts to the output line. It's enough to pull the voltage up to 5, but only if nothing else is trying to fight it. I know I'm damn close to getting this. I know I'm damn close to understanding this. It's gonna click one day. If something else like the transistor tries to pull the line low. So pulling the line low means connecting to ground, basically. It can easily overcome the weak pull-up. If the output isn't connected to a digital input with a defined internal state, there's no pull-up resistor. There's nothing forcing the voltage any known level. Now we're getting into the real question you're asking. And it's a sharp one. Most digital inputs are high impedance, called high Z. That means they don't draw any meaningful current. They're designed to observe voltage, not affect it. So when the transistor is off, yeah, okay. Alright, that does. This is bloody difficult. Oh, okay. Okay, I mean, what the hell is this like? Sure. Let's see this. I think I've just about internalized. Right, so we got our 3.3 volt logic connected to base, NPM, in ground. 5 volt going through 10K resistor. The transistor collector goes to that same output line, When it turns on, it pulls the line low. The ground. So. What the hell? What is this? I mean, I could do a simulation and okay. I mean, let's see if this works. Valstad.com/circuit. Can you open the link? Oh. Open link. So how do you do the thing? Circuits. Transistors. NPM. Okay. Base voltage, huh? I see. So there's like a tiny current going through there. 1.1. Yeah. I didn't think they had a linear response though. I thought like the whole idea of these transistors was that there was like an active region or something. Like where these could be used as like an amplifier. Oh, maybe that's what this actually is, like. Yeah, so that's when it's actually saturated, and anything above that, it's not going to increase the current flow or something. Yeah. So that's like 5 volts AC. Oh, okay. Alright, anyway, I'm just around here doing nothing. Let's get back into the job at hand. Really what I want is like, it'd be cool as if this thing had a 40-pin header, like, model that I could use. So if I went to the PCB and rebuild, yeah, I really don't have anything for that. So let's go back to the schematic. What about this thing? We're gonna go update symbol from library. What about a footprint here? We're gonna go, what about a DIN connector? Axial DIN. Oh, that's resistor. So what about a DIN? We got creepers. There's a lot of bloody things in here. PCB symbol. Crikey. So I don't know how I'm actually gonna model this, because I need some noodles. Food. VGAs. Wow. Connector pin header. Oh, yeah, it's like these things. This is exactly the kind of thing that I need. So I need to measure, I need to get my trusty, I need to get one, and I need to measure. Oh my god, living up to Name. And so gonna walk away. Bloody bot. Alright. I think I might need to go make some noodles. Food. Better. Okay. One by 05. I mean, this looks exactly... it doesn't quite look right. A lot of like generic. And the staggering I'm looking for quite unique. I don't think I'm gonna find. I mean, this just seems like a crazy way. Connect to pin headers. I mean, this is the closest thing I can get, but the problem is my this thing doesn't line up. Like, this is too lined up exactly. And it's also got like a it's also got like a ground connectors, like for the case. Inductors. Inductor, lead, capacitor, diode. D sub. No, not D sub. I've got connector pin socket. Oh, this ain't right, eh? Ain't right. Terminal block. Nope. Nope. None of this. None of this rubbish. I really need to start actually, like, stop messing around with this freaking circuit diagram and actually get building something. Otherwise, I'm going to get to the point where I hate to say it, but I'm going to get bored. Yeah, okay, this is absolutely wild. Hand soldering. There's so many. This is just insane. Oh my gosh. Filter by pin count, 5. Well, there we go. That helps, doesn't it? Apply footprint filters, done. Connector. I don't know what a high rose connector is. Don't know what any of these things are. TE connectivity. Connect to Phoenix. Can tell these aren't right. Threaded flange. Great word, flange. Love it. Nope. No, not Molex. We're not doing Molex stuff. What about valve? Nope. Terminal block? Nope. Oh, terminal blocks. That's the word I was looking for before. That's what I was trying to find. Okay. Ooh, no. Mini XLR 5. Definitely not, but close. I don't know how that's close, but makes me feel better to say that. I sound drunk. I'm so tired. And the reason I'm tired is because I'm actually not making any progress right now. I'm just clicking through bloody in footprints in KiCad. Uh-oh. My battery's running out on my mobile camera. That's not good. Terminal block? No. Filter? No. Nope. I mean, these ones are the closest. Definitely these are the closest. But they're not right. So I can't use them because they're not right. So there we go. What about MIDI? I bet if I typed in MIDI, it wouldn't work. Yeah. Oh. Okay, KiCad. Let's have a look and see if there's like a way to do this. Like, how can you KiCad MIDI connector footprint. There's no MIDI jack footprint, which is reasonable. Why is it reasonable? What's wrong with MIDI? There's nothing wrong with MIDI. It depends on the part, but mouse sometimes has some component files. Are you looking for something like this? If so, then this guy has one. Voice. That's exactly what I'm looking for. That is it right there. That's precisely exactly the right thing I'm looking for. That's exciting. Okay, let's go. This guy has it. 7805. Eurorack components and footprints for KiCad. Oh, this is why I love open source, man. Thank you, dude. This is amazing. Nebs, you're a legend. Is there a way I can just like say thanks? T and N are reverse. No, that's fine. Let's go Eurocad.pretty. What does that mean? These are all footprints. So I've never installed these before, so we're going to have to learn how to do that. I'm very excited now. This is great. MIDI DIN 5. You beauty. So how do I do this? I can download the thing. Download zip. Extract all. Good. You're a cat, man. Bloody hell, cats. Stop fighting. It's okay. Okay, I'm gonna have to go split these cats up there, B. Should have them. Oh, a lot of people. Okay, I need my battery bank. Need my battery.
3, 2, 1, 0, 0.
Oof. Beauty. And then my noodles are almost ready. Well, kettle's almost. Okay, so let's have a look and see here. How do we import footprints? How do we import footprints? Let's go to the footprint symbol library, footprint editor. But like, you can't make 3D models. Add an existing library folder. Import. So what are we... all supported formats. So we're looking at KiCad footprint files, legacy footprint file. So basically, I want to copy those and I want to shove them in my projects electronics folder. And we'll call it, we'll organize it nicely. We'll call it KiCad footprints. And we'll shove it there. And I'll just rename it, not to master, because I don't care about GitHubby stuff here. So why isn't it letting me rename this? Okay. Go Euro. Oh my goodness. Why is nothing working? My keyboard stuffed? What's going on? Turn it off and turn it on again. Oh, whatever. Eurocad.pretty. Can we just select all of these at the same time or not? What about import? What about add library? Choose the library table to add the library to global. And then how do we... Now it decides to let me rename the file for some reason. Whatever. Okay. Eurocad master. Why is it doing this to me? Eurocad pretty. Select folder. There we go. Yes. We now have Eurocad MIDI din. Beautiful. Okay, so what we are going to do is double click on this. We're going to go here. We're going to go Eurocad, and we're going to go MIDI din 5 pin connector. Yes, that is exactly what we want. That is so freaking cool. I love it. I love it. Look at that. Beautiful. Okay. That's great. 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 All right. Let's get out of there. And we're going to go okay. Exactly what we need. Now this thing. I'm not sure if this is gonna be the right... I don't know if this is gonna be the right way to do this. I think I'm gonna have to do something a bit more custom. I think I'm just gonna have to do a connection point, like a pin header. We'll figure out how many pins we need, and then I'm just gonna make my own. So I think I'm actually just going to delete all of it. Alright, I'll go get my noodles. Oh yeah. Noodles. Noodly, 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 noodly. Okay, right, calm down, buddy. Calm down. I need some like more intense music here. I need some like dubstep. Something really freaking like gonna get me going. I need some like royalty-free electronic. Electronic music, no copyright. I just want not enough.
That client review was brutal.
We're gonna be underwater for weeks.
I'm already so pruny.
This is fixable. Just use gray.
Already so pruny. Free background music, creators and streamers. Well, that's me. It's also slow and quiet. I want. So maybe I need to actually type in like something a little bit more extreme. DMCA free lo-fi. I literally just typed in like dubstep. Not that I don't really want dubstep. I want like, I know what I want. In fact, actually, I'm pretty sure that I had a playlist on Spotify which was called Winamp Greatest Top Electric Hits. Winamp Top Electric Hits by Sia. And this isn't like DMCA free though. Oh man, I'd love to just play Alt J. Play whatever music I wanted to play. Blah, blah. Not like they're losing any money. Really. Seriously. Well, I guess. Well, the thing is, like, you could say they are losing money because I'm not paying them royalty fees. But I'm not going to be paying them royalty fees anyway. I don't want to play, I don't need to play that music that bad that I'm going to reach out and pay. So they're not winning or losing. It just doesn't. Okay, here we go. Melodic dubstep trap something. Blah blah. I really don't want vocals. Okay, I think I'm just going to go back to my I just think I'm going to go back to the thing. Oh god. What about these this got to be copyright. So 12 hours of copyright free background music. Yeah, let's just roll with this. Fine. Deal with that. Okay, what's wrong with my headphone cable? Everything's wrong. I am about 10% as productive tonight as I was last night. Perhaps a delicious bowl of pot noodles will make me feel better. Okay. Whew. Temperature. Still through the roof. Can't eat them yet. Okay. Wow. Okay, let's go pin connector. Go pin header. What about pin even pins? Generic connector, single row, 101. Yeah, see, that's kind of cool. Oh, generic connectors. This is what I want, you see. This is good. This is good. Ah, burning, but I couldn't wait anymore. Okay. So how many have we got? We got 4 DINs, so we need 8. No, 8 plus 5 plus E. So that's 10 pins. It's a 10 pin connector. So we're gonna go con 1 by 4, 1 by 10 pins. Beautiful. I'm gonna shove that there. We're gonna rotate that around so it's around the other way. Is there any way to flip it so it's like we can mirror on the x-axis? Yeah, that's good. Like that. I like that. I like where that's going. Yeah, see, that's going to GPIO 15. In fact, this should be 3v3. We're going to go add, and we're going to go... I wonder if we can label each one of these. Reference J2. Oh, I see, yeah, okay. So pin number 1, pin name. Can we change the pin name? Not. Pin function. Base name. Relation model. Can't change the pin names. What about labeling? Can I do that? Pin helpers. No connect. Net label. Here we go. Net label. Pin 1. We're going to call this 3v3. Yeah, I like that. That looks good. That looks good. Yeah, happy. Happy. Happy, happy, joy, joy. I've... 3v3. What I could probably do is like actually global labels. What are global Directive label. I don't understand the different label types. Symbols and symbol libraries. Man, these noodles are the best. So good. Yum. Oh, makes me happy. Jumper. A human readable name. PCAD bus. The next... Oh, shit. Okay, the next step up from wire is blue line called bus. That's pretty cool. You must add a wire to a bus entry to tell KiCad that you want the wire to be part of the bus. Okay. Mismatched pin names. Yeah. Bus versus pin labels. Okay. Local labels versus global labels. What if your schematic beyond... Oh, beyond a single page. Okay, so... That's cool. Hierarchy pin. Ports into and out of the sheet. Okay, that's kind of cool. I like that. Alright, so basically what that's told me is I just need... What's a directive? Oh, okay, here we go. What's a directive label? That's the one that I didn't understand. KiCad directive. So oh, this is getting a bit too advanced. I think I'm getting too far in. Local labels connect items located in the same sheet. Okay, so I need to take a note of this. This is important. Making and coding. We're gonna say we're gonna add a folder here, I think, because we're gonna use KiCad quite a lot, so stuck it in there. New folder, we'll call it KiCad. And we'll create a new item, and we'll call that new item, what are we gonna call it? Like, we'll just call it general reference. And we'll give it a heading, which is, maybe labels, schematic, symbols. We'll call it main documentation. KiCad docs. I don't know why I'm so resistant to going to the freaking docs sometimes first, and then I go there and it's like, oh, all of a sudden everything makes sense. And it's like, you're kidding me. Gerber viewer. Weird. Oh, the shit is cool. Oh, PDF. Okay, so children, that's kind of cool. So drill down. What about, buses is kind of cool. I really like that feature. Gonna use them yet, but okay. You got a our flag. Right, I see. Interesting. Yes, very interesting. Alright, well, I think what I'm gonna do is just continue on with what I was doing. This is gonna be 3v3, so we're just gonna go place a net label. And it's gonna be 3v3. There. Why do I keep zooming in all the time? Oh, wrong button. And this is going to be that's going to be 5 volts. Call that one 5V. Yeah. Bruh. No. How do I grab this now? Oh my goodness. Oh my goodness. Very good. We got it. No worries at all. Okay, 3v3, 5 volts, which we're actually not going to use yet. And then we've got this, which is GPIO. That's going to be, we're going to add a label. So that's L for label. We're going to call it GPIO 15. And that's going to be RX 0. Yeah. Good. And then these are going to be all the other GPIOs. Oh, I mean, maybe I should do this way. Maybe I should go 14. Maybe we should go lowest to highest. I mean, it kind of makes sense, right? So if I go back to my pinouts and UART here, we've got 0, 1, 4, 5. Zero, which is RX2. No, it's not. It's TX2. And that's going to be GPIO 1, which is RX2. And 4 and 5 is 3. TX3, is that right? TX on GPIO 4? TX, yeah, 5. RX. And 2, 3. 12, 13, 14, 15. Gonna be 12. That's gonna be TX5. Is it TX5? 12. 13. 14. It's gonna be TX0 and 15 is RX0. Okay, cool. Yes. That's our 10-pin connector. This might actually work out really well. Hmm. Although, actually, yeah. I don't know if it is going to be that simple. Although perhaps I could feed the power through a different connector. Update symbol from library. Change symbol. So we're going to have to go to, man, maybe, and then we're probably going to want a signal. We're probably going to want a signal for each. We're going to want a signal for each port. So we're going to need another 4. So really we're going to need a 15 pin socket all up. Yeah. Yeah. Okay, and we're gonna call that one ground. And these are, they're like gonna be cable selects basically. Oh boy. Oh boy. Yeah, look at that. And then we've got the 4 selector. Huh. Oh, would you look at that? D-sub connectors. Nah. Nah. We're not using D-sub connectors. Screw that. Connector. Phoenix MC connectors. What are they? These have like a, yeah, look at those. Do 3D viewer in its own window, please. Kind of cool. But that's not what I want. Empty USB. I do like those connectors. I've used them before. Potential. What about just pin headers? Yeah. Good cat. Horizontal. Socket. I mean, what if I just do a 16 pin connector? Because then I can do a 2x8. Yeah, see, these connectors are really cool. Stocko connectors. I gotta see which connectors I can actually get hold of as well. Yeah. Rose. It doesn't actually have the IDC. Yeah, so IDCs are good. I could use an IDC connector. Terminal block. These Stocko connectors, right? So 14 or I mean I could just go wait, what? 1x15. Oh, that's what I should use. 15 pin Stocko. Have a look around 15 pin. Oh, let's go J car. Go to Dean. DB15. Seems a bit freaking. Seems pretty intense. Connectors kit was popular. What if I just go 6? Okay, I'll go 16 pin. IDC right angle header. That's kind of what we. Available variants. Yeah. And then we need the socket as well. If we just go 16 pin IDC, I think we'll be golden. What do I think? Oh, come on, IDC. IDC header. 2x8. And we want that horizontal without a latch. Perfect. Yaha, that's what we want. Yes. That's it, baby. Okay. So we're going to actually go 2 by IDC 2 by 50. Warnings. No net found for component J2. Add 16. Man, look at this, this is wild. How do you stop stuff crossing over like this? Is this what circuit design is all about? Bloody hell. I reckon this IDC connector, if we put it around that way. I think that'll kind of work if it goes under the resistor, right? Then this kind of goes like that. I can see why 2-layer PCBs are a thing. sketch. Route single track. Tune the length. Yo, this is crazy. This is cool. Frick. Well, this is the funnest thing I've done in a while. Pretty lame, doesn't it? Yeah, this is crazy. What the hell? Okay. Why am I so happy making a circuit board of my own? I mean, why the hell? Yeah, why the not? Like, the question is, do the wires don't, yeah, all right, yeah. You've actually got to like sort of get your components organized before you do any tracking. Okay, well, that's fine. What we'll do is we'll continue on with the other channels back in the schematic here. So we'll do like this. Roll. Right. I think I just understood the point of that whole hierarchical thing. Because what I can do here is I can define all of this as like a as a unit of yeah. Does make sense. I totally didn't even see that there was a sidebar down the side. Good to know. Place sheet pins. Draw hierarchical. Sheet name. We're gonna call this a MIDI DIN IO. We're going to call it a MIDI DIN IO unit, but pop that there. Alright, so this is going to be, we're going to have to convert this to a global, change to global label, hierarchical label. Okay, so that line there is going to have to be one of the GPIO pin, which update. So how do we update the hierarchy? I don't know how to do this. Still new. So what I think I need to do here is go add round. Rotate that around. Probably actually just get rid of that. I mean, that kind of makes a bit of sense, does it? Yeah. Okay. Hierarchical schematics. Single root sheet and additional sheets created as subsheets. Sheets can be included in a hierarchy multiple times if desired. Carefully drawing a schematic as a hierarchical design improves schematic legibility and reduces repetitive drawing. Creating a hierarchical schematic starts from the sheet. Process is to create a subsheet, draw the circuit in the subsheet, and make the necessary connections. Connections can be made between nets and in a subsheet and nets in the parent sheet. Hierarchical pins and labels, or between any two nets in the hierarchy. using global label. So hierarchical pins are more like yeah, we'll see how it goes. So electrical connections between sheets are made with labels. There are several kinds of labels, each with a different connection scope. Local make connections within a sheet. They cannot be used to connect between sheets. That makes total sense. Global labels make connections anywhere in a schematic, regardless of sheet. Global labels are added with the A button. Yeah, with the global button. Hierarchical labels connect to hierarchical sheet pins accessible in the parent sheet. Hierarchical designs rely on hierarchical labels and pins. So labels and pins are two different things. Make connections between parent and child sheets. You can think of sheet pins as defining the interface for a sheet. Yeah. Hierarchical labels within the child sheet connect to corresponding sheet pins which are visible in the parent sheet. Right. Okay, I get it. I get it. So we got to define our hierarchical pins in the child sheet. It's like 3v3. And this is going to be right, okay. I think I get this. This is kind of cool. So we'll go place a hierarchical label and we'll call it UART 3v UART RX. Syntax help. This is crazy. I don't understand this. Net 1, net 2. Yeah, I don't understand this. I see. Right, so these are just like lists. I don't think I need to worry about it though. So that's an output. There's UART RX. That's global ground. 3v3 in. So sync sheet pins. Add hierarchical labels. This is what I don't understand. What's this hierarchical labels thing? No, because that's a pin. Yeah, I see. Okay. Good. So we're going to do a net label here, and we're going to call this one 3v3. And that's going to go there. And that can look like those other ones. Okay, and this one's going to be like net label, and this one's going to be... We're going to call that one 5v. Pop that there. Yeah, okay, so then we can take this, we can copy it, and we can attach that there. And this is UART RX. And this is going to connect to like GPIO. $15. Like that. So if I save this and I go to the PCB viewer, it does work. It's crazy. Pretty cool. So I've now got the subsheet. So this stuff here is actually a subsheet. This is the main sheet, but it's linked it all up together. How neat is that? That is neato. That's pretty neat. Oh, I've got to get that video. I've got to do that. I've got to do that for the stream. I've got to have that as a meme video. A meme video. So that's pretty neat. Nietzsche walk. Classic.
Turn your best idea.
For me,
Nature is one of the neatest things on this planet. That's why Rodney and I started Nature Walk, because we want everyone to know how neat nature is, instead of just me and Rodney knowing it. How neat is that? That's pretty neat. Without a doubt, coming out into nature is one of the neatest things there is to do. But you also have to be careful. That's why I always try to pack a gun. It's just a little bit, pack some heat. Now this isn't much of a big boy. I don't want to kill the animal, but I do want to warn it and say, hey, I think you're pretty neat, but I respect your distance. There's bears out here, there's mountain cougars, and biting goats. How neat is that? That's pretty neat.
What is that? So I gotta get the, that's pretty neat.
Oh, wow, score! Look at this. This is an aspen. You can tell that it's an aspen tree because of the way it is. Wow.
Classic. This is the way it is. Right, anyway.
Wow. What a beaut.
What a beaut.
You know, it'd be a great capper to a great day. It'd be seeing a wild animal. I always get real excited at the opportunity to maybe see an antelope or a fox, you know, or some sort of mountain beast. So what I do sometimes is I'll try to, you know, shake things up a little bit, get the earth moving, and call out to them, you know. Here we go. Up, up, up. Hip. Hip, hip, hip.
Alright.
Come on.
Yeah, Lenny.
Come on, girl.
Yeah, Lenny.
Nothing. Gee, dang it. I don't see any coming out.
You dang it. Alright, anyway, that's enough of that. What's the time? Almost 11 o'clock. I'll probably go to bed. Oh, I did not make as much progress as I wanted to, but I made some progress. Some progress is better than none. I've learned a little bit more of KiCad, which is a good thing. How that's potentially going to work for me. So I reckon like aligning these things just vertically kind of makes sense. And then they're like, is that enough room to draw traces? Like, if I went, I mean, I think the answer's gonna be yes. Of course it is. Look, it's very unlikely at this point that there's anyone watching this video at this point later on. If you are, hi. I appreciate it, but subscribe or whatever, follow, and come join live next time as well, because I love my old channel where I gamed. I have a lot of people, like a lot more people. Not saying, yeah, that sounds. It's fun to talk to people, and I think that gets my energy up. So yeah, feel free. Join in the live stream. It'll be worth it. Why does it want to go around that way? Why can't I just, like, oh, you can. Okay, you can tell it to, you can click. Makes sense, right? Awesome. Okay. Well, now what I need to figure out how to do is, like, now I've got this. Oh my, what's going on here? Now I've got this schematic here, like this. What I need to be able to do now is run the footprint assignment tool. Hey, that's cool. I didn't realize this was a thing. That's pretty neat. Automatically assign. Cool. Okay, well, it's a bit funny, isn't it? Because, like, how does it know? Anyway. Select on PCB. Auto place fields. Yeah, I don't get the point, like, oh, so hang on a second. You could just do this, right? Oh, I think I get it. I actually think I understand. So if I edit this, is there a way, edit sheet, page number? So how do I know what file this is pointing to? Seems weird having, like, multiple sheets. I feel like this just doesn't, it just doesn't feel right. But it might be. You really need another sheet for the same module. It's pointing to the same file, which is a good thing. That's what it's supposed to do. So can I not call it the same thing? Okay, well this is going to be RX2, which is going to be GPIO1. RX2. And so now I go to the schematic. If I go to the schematic now, I should be able duplicate sheet name. Yes. Relink footprints based on the reference designate. Replace footprints with those specified in the schematic. Yeah, right. I just realized my music's finished. That's probably a good sign that I need to go off. I would say. Excuse me, what the heck? What is that? Okay. Random track in the middle of nowhere. You two, where's the R3? Why doesn't this one have... Ah, it is there. Perfecto. There's something else stuck behind here. I'm not sure what it is. Okay, well, I mean, it's not the worst, like, way to do it, I guess, is it? So sheet name unit 2, and then we'll call this unit 1. MIDI din IO 2, MIDI din IO 3. Oh, there we go. MIDI din IO 4. Root. And now we can do some labels. So we can go RX2, we want RX3. Go on to there. And 3v3. There. 3v3. Then we want GPIO 13. Okay, so if we save that, we go back out to the PCB and we go and we go update. Oh, the warning is warning no net found for component J2 pad 16. No pin 16 and symbol. Here. Wait, do these things interlock? No, they don't. Not quite. I gotta say, for my first foray into circuit board design, this has been extraordinarily fun. Funner than I thought. I don't know why it wouldn't have been fun, to be honest, because this is exactly the sort of crap that I love doing. Wouldn't you know? There. That one goes down here. Beaut. Now where that jumper there? Okay. Now you see that's kind of cool, ain't it? Neato. So there are our 4 connectors. Now, this I don't understand. Why are there so many 3v3s? Doesn't make any sense. What? GPIO 14. 3, 5, 7, 9, 11. No. 2, 5, 7, 9, 11. 2, 5, 7, 11. What? Any sense whatsoever? Electrical. 2. Yeah, what? To make. Wait a minute. Is it because I named that the same? Should that not be called? Should that be 3v3 in? Maybe that's it. Maybe I'm stepping on the name. Go into the sheet. Like, enable 3v3 in. And then I save that and I go back out to the front page and we go sync sheet pins. So okay, so this is a pain in the butt if you have to do this. When it comes. God, imagine if you got, oh man, you could get, this would drive you insane if you got this wrong. Like, oh, lucky I got a very small schematic here, so not much for drama. All right. 3v3 in. So now if I save this and I go into this and I go synchronize, I still, what? Why is it doing that? I don't get it. One, is something wrong with J2 here. Something's wrong with J2. Well, that's pretty cute. Isn't it? Look at that. Freaking cute is that? Huh. Huh. I love this. This is so cool. Hello, electrical engineering. Now, I don't know what's going on here. Oh, it's hiding behind there, isn't it? Yeah, that's annoying. Why doesn't that link up? Ugh. Gives. Okay. That is annoying though. Obviously. A little bit of alignment. Alright, so how do you make a board edge? I don't know what a roll area is. It's really bothering me. Oh, 3v3 thing. It's not. It's not correct. We've got 0, 4, 12, 14. Okay, so maybe what I need to do, yeah, because I'm not, I guess in some ways I'm not ready. So in some ways, like I need to do a no connection thing. Like I need to do add a symbol and go NC. Um, Not connected, maybe. Oh, unless there's already, yeah, it's over here. Don't even need that. So can I just drag this into place? Yeah. Well, that's stupid because I have actually connected the 3v3. So let's get rid of that. 5 volt I haven't used yet. GPIO, all the RXs I've used, so we can get rid of the RX ones. That one, that one. Save, and we can go back into the board schematic and we can and it's still absolutely I mean, god damn it. Why? Ad number 11, net name 3v3. It's not though, is it? Where's it getting 3v3 from? Ad number 11. Connections. How is it getting the net name of 3v3 from? Well, that was pretty bad. Literally failed everything. All right, so we need to specify some of these not connect. Go back to here. No net found for component J2. Add 16. No pin 16 and symbol. Oh, you know, that might be why I've screwed it up. That might be why I have screwed it up, because this is 15 pins, not 16, you dork. So we're going to go change symbol, and we're going to go by 16 pin. And we're going to go change. And now we have the right amount of pins. Yeah. Save this file. We'll go back to the PCB and we'll regenerate. It's beautiful. And I don't know why, but for some reason, this is still doing the thing. Something weird going on with footprint mapping. IDC 2 by 8. Change footprint. IDC header 2 by 8. This is freaking bizarre. This don't make any sense. I think I'm misunderstanding how to use hierarchical pins. Only explanation that I've got is that I don't know what the hell I'm doing. So at this point, it becomes time to effectively give up. Oh, I'm so tired. Okay. Yeah, this is messed up. Okay, 2 by 8. Footprint. IDC header 2 by 8. Datasheet, none. Change. Is there like a con 2 by 8? Like 02 by 08. There is. Connect to generic. Hmm. Yeah, nice. Okay, well that didn't work. Let us go here. I'm past that point now where I'm like, I just want to get this working so I can go to bed, you know? Like what I should do is go to bed and then I'll get it working tomorrow. No? That that should be what I do. But that ain't what's happening. So we're gonna go 16. We're gonna go 15. We're gonna go 14. 13. And we're gonna go 12. Alright. And we're gonna go TX2. Can connect to the RX2. RX-TX3 and RX3. I kind of like that actually. I don't know what's that can go, that can go, that can go. Bloody oh. And then we've got 1, 2, 3, 4 on that side. Which I don't love, but I don't hate either. What I could do is move this 5-volt pin down here. And then we can plonk all of these. Like that. But what I kind of want is I want the TX and RX. Do I even care? Oh, there we go. I've still got 4 3v3 pins for some reason. And I don't know why I've got 4 3v3. What I should be getting are these dudes. Yeah, I get. You know what? I actually think this is correct. Oh, screw me. They are connected to 3v3. Of course they are. It gets grounded. Oh my gosh. All right, well, at least I kind of, you know. Oh, whatevs. I'm going to claim that as a win. I'm just going to... Oh. Okay. I think it really annoys me about myself. Just talking through things like, that can go there, that can go there, that can go there. No one wants to hear that. I don't. Okay. Beautiful. It's time I got my grumpy ass to bed. All right, bye bye.